Welcome back everyone, and welcome to episode 3, where we start to learn about the main SQL objects and we start to write some SQL code. Brilliant stuff. Right, the aim of this episode is to familiarize you with the main database objects that form the backbone of all the work that we'll be carrying out in the remainder of this program. So first of all, we're going to look at databases, creating those, changing the name of those and deleting them. We're going to have a quick look at schemas, what those are, what they're all about and how they tie in with things. And then we're going to have a look at tables. We'll be creating those, the common functionality within those, and we'll be looking at the columns that form those tables and the data types, which is very important when you're creating a table. So let's fire up SSMS and get coding. Scroll on down to where you've got your SQL Server Management Studio. I'm going to pin this one to the start, like that. Right click, pin to start, and then it's there for when I need to use it. So I'm going to click on that. And depending on the speed of your laptop or PC, it could take a little bit of time to fire up SSMS. But once it's up and running, once again you'll be greeted with the connection screen, and it should pop up with the server name. If not, you know what to do to type it in and then connect from there. So there we are, we've connected to our SQL Server instance. Now I've saved a query that I created earlier, and to open a saved query, all you need to do is head on up to Open File or press Ctrl O, and that will open a screen for you to locate where your scripts are stored, find the one you're after, double click, and it will open up. Now if you haven't got a saved query and you're starting from scratch, just head on up to a new query up here or press Ctrl N and it'll open up a fresh new query page for you. So there you have it. That's our script, and as you can see, it's just simply a block of text. However, SQL Server will look at that text and decide which is just notes and which is actual code that it'll need to run. And it's very helpful in so much that, as you can see, it's all color coded. So looking first at this block of green text here, anything green is pretty much text that SQL Server will ignore when you execute this query. So you can put notes in to your heart's content. Now there's two ways of doing that. One, if you need to comment out a big block of text, several lines here, as you can see, we're going to put a / asterisk at the beginning and then an asterisk / at the end. So you can see if I delete that, everything turns green. So it's expecting everything to just be notes. We'll put in the asterisk and / back there and it returns to normal. So that's one way you can comment out notes that you want in your code. Another way is simply to put two dashes at the front, two minus signs. Now you can simply just type those in, or you could use these two buttons at the top here, comment out and uncomment. So if we uncomment those, as you can see, the two green dashes have disappeared and it's changed color. So SQL Server is expecting this to be code, and as you can see, it's got those red squiggles underneath, just like when you make a spelling mistake in Word. That's to tell you that there could be something wrong with your code and it may not execute because of that. So we'll go back up here and comment out that selected line. And there you go, turns green again, and it's just notes for our own information. Now it is good practice to put notes in where you can, and the more complex your code becomes, the more you'd want to put notes in at every level. And it's especially useful when you're working in a shared development environment, and there's other people that may have to jump into your code and have a look and maybe fix bugs. And putting in notes in key areas helps them to just narrow down everything in your code so they can quickly fix it if needs be. So going forward, when we're doing these episodes, please put comments in. You don't have to, but it's a good habit to get into, and we'll take it from there. Going down, what we're going to do then is we're going to create our very first database. Now it's easily done if you type out create database. Now you can put that in lower case as well. As you can see, there's no issues with that. SQL Server is not case sensitive when it comes to writing out functions. Personally, and I'm going to Control Z here to undo, I personally like to type it out in capitals, but that's just my personal preference. It's up to you how you want to type that out. And then for spaces, I'm going to use tab instead. So if I delete those two, instead of pressing space along there, what I'm going to do is hit tab a couple of times. And tab just keeps things really neat. It's quickly line things up. As you can see here, all my code is neatly lined up. And again, it's purely up to you how you want to lay out your code. But the neater it is, the easier it is to see what's going on and to find areas where there might be something going wrong. You could home straight on there and fix those bugs. So once we've typed create database, we then need to give our database a name, which is what I've put in here, my first database, and I've surrounded that by square brackets, as you can see here. At the beginning and at the end we've got an open and close square brackets. Now you don't need those if we delete them as such, and that's fine, but it's good habit to put those in, because if you have spaces, for example, as you can see it's giving errors. There's some red squiggles showing up, but if you had square brackets, as you can see, it'll run that code fine. In addition, what we don't normally do when creating databases is we don't tend to use spaces. If you do want to use a space, normally we'd put an underscore, which is underneath the minus button on your keyboard. As you can see, that functions fine. And you can put characters in, etc. But what we're going to do to keep good coding practice is we're going to have no spaces, capitals on the first letter of any words, and we're going to create our first database. So once you've typed that out, highlight that line and hit execute. There we go. It says commands completed successfully. So let's head across to the Object Explorer and see our database. There it is, my first database. Now if your first database does not appear there for whatever reason, simply click on databases, right click that and hit refresh, and it will show. Sometimes the Object Explorer is a little bit behind and needs a little bit of a refresh to show your latest changes. So our first database is in there. So we're going to head back to our query window, hit Control R to remove the messages screen, and a quick note as well on semicolons. Now semicolons is not something at the end of your code, is not something that's enforced on all functions. Create database was one of the very first functions that was available in SQL, so they wouldn't have had the semicolon enforcement. However, in later versions of SQL, where they do have more up-to-date functions, newer functions, they will require you to put a semicolon at the end of your code. And if you don't and try to execute that code, it may come up with a warning in the results screen asking you to put a semicolon in. So it's good practice to put a semicolon in at the end of any block of code that you're going to run. So that's creating a database, and we've created our first database. What happens if we need to rename that? We don't like the name, so we're going to change it. Simply type out the command alter database, and once you've done that, we need to tell it, SQL Server, which database we want to alter. So we're going to go to type in my first database, and then we're going to type out modify name equals, and then we're going to tell it the name to alter it to. Pretty simple and straightforward. So once we've done that, semicolon at the end of our block of code, highlight that and hit execute. There you go. The database name has been set. Now, as you can see from the Object Explorer, we've still got my first database showing there. So we're going to have to click on databases, right click and refresh. And there you go, refreshed, it's showing the altered database. Just a quick note, Control R to minimize the results again. Just a quick note, if I hit execute now with nothing highlighted, SQL Server will try to run this entire block of code, which is not what I want it to do at this point in time. So if I just wanted to execute a small bit of code, then we just highlight that code and hit execute. So we've modified our database, we've changed the name. What if we don't want that database anymore? Well, we use the term drop a database. Now we use drop as opposed to delete because in SQL terms, any object that we want to get rid of within our SQL Server, we say drop. However, with delete, that's all about data. So we delete data, but we drop objects. Now another way you can do that is simply right click on your database there, go down to delete. It doesn't say drop, it says delete, I know, that's just the way it's done. But what we're going to do, we're going to use the code. So if you want to type in drop database, and then we need to tell it which database we want it to drop. So if you highlight that and hit execute, you see the command are completed successfully. Again, head on to databases, right click and refresh, and you'll see our database is gone. Close those results screen. Now you'll see that there are some red squiggles under this, however the code still worked. But what SQL is doing, the IntelliSense that's enabled, is it's trying to ensure that this entire block of code that it sees there can be run in one pass. However, as we're executing lines of code one at a time, then it's safe to execute this bit even though it's got the red squiggle under there. Right, so that is it for databases, everyone. At this stage, you may want to save your script. And as you can see at the top tab here, there's a little asterisk, and that means that the script is unsaved. So all you need to do is Control S, mine is saved. Yours will probably ask you, open up a window asking you where you want to save it. Simply find a location or a folder in your hard drive and save it down. You can name it anything you want to and hit save. You can also click on these icons, save episode, save all, etc, etc. So there's many ways of saving it, but just like Windows or Word or Excel, you can just hit Control S to save. So that's databases. What we're going to do quickly is we're going to create my first database again. So highlight that, execute. That just makes sure that we've got a database to work with. Control R again. And now we're going to have a look at schemas. Now schemas are the next level down from databases, and all a schema is effectively a container. And so that what you can do is you can group tables into that are very similar or do similar things into a schema, in a specific schema. Now every database you create comes with a default schema called a DBO, which is database object. However, what we're going to do is we're going to create our own schemas. So first of all, if we look up on the left, you can see here the available database is master. And as we learned from the second episode, we don't want to touch the master database or any of those 4 databases. We don't want to go near those. So what we need to do is we need to change the database that we're working in. Now there's 2 ways to do that. You can click on this little drop down. It will show you all the available databases, and you can click on my first database, or you can use the term use followed by the database that you want to use and then go at the end. So that will set that. Hit on execute, and there you go. Command completed successfully, my first database. Now if you type in a database here that doesn't exist, then it will come up with an error saying can't find it. So make sure your spelling's correct, or just use the drop down here. Okay, so that's changed that. Now let's create the schema. All you need to do is type create schema, and let's call it sales. So we're going to create this sales schema, which is a nice container to put all our sales related tables into. So I'm going to highlight that code and hit execute. Command completed successfully. So we've got our schema. Now if we were to run that create schema on sales again, I'll hit execute. You'll see that there's come up with an error that there is already an object named sales in the database. And that will be the same if you try to create a database that already exists, or a table that already exists, or any object for that matter. If it already exists, it won't create the new one. And that's all there is really about schemas. Very simple, very quick and effective. Lastly, we'll talk about tables. There's no point having a database without any tables to store your data in. So once again, we simply use the command create table, purely and simply. And then what we need to do is we need to specify the schema. Here it is, which was sales, which we just created, followed by a full stop. And then we need to specify what we want the table to be called. So we're going to call this one customer sales. As you can see, I put everything in square brackets, which is good common practice. So that is going to be our table. Customer sales under the sales schema, separated by that little full stop. Now to start creating your columns, because a table needs at least one column in order to be created, you start with a round bracket, as you can see there. So that is the start of your table. Now you're telling it after that command, right, here comes my columns, and we're going to put those in. So we're going to call our first one sale ID as such. Now what we need to do whenever we create a column is we need to tell it what data type is going to go into that column. SQL Server likes to be very specific about data types, and in this one we're going to put an int, which is just short for integer. In other words, a whole number. Now an integer ranges from just over -2 billion all the way through 0 and then over 2 billion. So there's a huge range of numbers that you can put in there. Very good range. We're going to use integer for there, but we're also going to do a nice little sneaky trick of putting in an identity. All this means is that we're going to get SQL Server to put in a sale ID for us. What it's going to do is it's going to start at 1 and then it's going to increment by 1. So every time we insert a row, it'll increment the sale ID. So we don't need to worry about that sale ID now. We'll get SQL Server to put that in itself. And these will all be unique, as it will increment 1 each time a row is inserted. Next, if we're going to include more columns, we need to separate them by commas. So there we go, we put our comma in, and it doesn't matter if you put the comma in at the end of this line or at the beginning of this line. There is a little bit of a debate going whether you should put commas after or before. I like to put them before personally, because it's easier to then comment out lines. So if I didn't like that, for example, I'll just comment it out, and it doesn't mess up with the code, as you can see. I'll comment that out. So we've got to put our comma either way in between the columns we are creating. Next column we're going to create is the customer number. So we'll type in that, and we're going to make it a char 6. Now char is simply short for character. So we can put anything in there, whether it's numbers, letters or symbols. And we're going to restrict it to a length of 6. So that means you can have up to 6 characters in the string that goes in there. Now, if you're working in a company and you're putting in customer numbers that are 10 characters long or up to 10 characters long, then you change it to 10. So the number you put in there determines the length of string that will go in there, and that all depends on the data that you're trying to insert into that specific column. Now if you did try to insert a row of data that has a customer number of 7 or more characters, it will fail to load because it expects 6 or less. You can have less characters than 6, but this will only accept a 6 or less. And what we're also going to say is the words not null. All that means is that we are expecting data to go into that column every time a row is inserted. So if someone tries to insert, or an application tries to insert a row into this table where the customer number is missing, it will reject that row and it will not insert it. So that's the customer number. Let's add another column separated by a comma again, and we're going to call this one customer email address. So you can either type that one out or pause it afterwards and type the whole block, up to you. But we're going to type that out, and we're going to look at a varchar, which is the next data type. Now the difference between varchar, which is variable character, and char, the one above, is that we are looking at putting in email addresses which have got a variety of length. You can have an email address which is 20 characters long, 30 characters long, 40 characters long, etc., all the way up to 50. So we use varchar because we just don't know the length of each email address that comes in. They're not a specific length or one length, but they're a variable amount of characters. However, once again, we specify 50, and I think if you have an email address which is over 50 characters long, that's a pretty long email address. But again, if you worry about that, you can simply change it to 100 to make sure it goes in. But bear in mind that you will be storing additional space on your hard drive, which is why we have these different data types. And we're going to specify null. So if the customer hasn't given us an email address, we will still accept that row if it's inserted into that table. So that's the only difference between null and not null, is that the null will accept no data, whereas not null will reject the row if no data is in that column. We're going to put in a country code, char3 as well, and we're not going to specify whether it's not null or null. Now the default is to default it to null. So if you leave that blank, you don't specify that it's not null, it will default to null. So people can enter rows within this table with a blank country code. Order ID is next, and we're going to look at the small int, which is similar to int. We're talking about whole numbers, but it's got a much less range, minus just under 32,000 all the way up to just over 32,000. Now the reason why we've got small null is that it takes up a lot less space on a hard drive compared to int columns themselves. So you can use small int as well. We're going to say not null for that, and then we're going to put in the order line ID, and we're going to call that tiny int. So tiny int, small int and int are pretty much the same except for the range itself, and the range for the tiny int is from 0 to 255. So very small storage on disk, but maybe not very flexible because it's a pretty small number. But you can still use tiny int if you need to. Order date time is next, and we're going to look at the date time, which is pretty much you're looking at the date followed by the time to a degree in milliseconds. I'm going to call that not null, and we're going to use a new function, new in this case, but a very well used function called default, and we're going to use getDate as well. All getDate does, and make sure you include the open and close round brackets at the end, all getDate does is it takes your machine's date and time and uses that. So what default will do is that if nothing's entered into this column when you try to insert a row, it will just put your computer's date and time in there instead. And that we're going to specify as not null as well. Small date time, this is just to show you a comparison, is pretty much exactly the same as date time, but without the milliseconds. So it's a little bit more user friendly. And again, we're going to go for not null and insert the system date at the time. Lastly, we're going to do the order date with a type of date, which is simply just the date minus any of the time. That's not null again, and we're going to default it to getDate. Now, although getDate is a date time, as you can see if you hover over it, it says it returns a date time. If you specify the type on your column as a date, it will only grab the date component from that date time and put it in there. So we don't have to worry about converting getDate into anything. Next, we'll put in an order value. We need an order value amount in there, and we're going to be looking at the decimal data type. Now that allows us to store digits with a decimal point, so we're talking about fractions, etc. And we're going to need to specify the length, which is 9 digits, and the precision, which is after the decimal point. So we're going to go for 9, 2, and we'll see what that looks like when we play around with data. We're going to say not null for that, and next we're going to put in the order tax. Now, difference between these columns and the order tax is that the order tax is going to be a function of the order value column itself. So what we're going to do is we're going to say whatever the order value is that gets inserted, the order tax is going to be 20%, for example, of that order value. And we're just going to let the computer SQL Server calculate that on the fly whenever a value goes in. So what we're going to do is we're going to say order tax as, and that's the keyword, as, and then we're going to type out our function here. So we're going to take the order value and multiply it by 0.2 to give us 20% of that order value. So now every time a value gets inserted into order value, it'll automatically calculate the order tax based on this formula here. Saves us quite a bit of work. And then we're going to put an isReturn, what I call a flag, in there, and we're going to use the bit data type. Now the bit data type is very, very small. It's literally a 1 or a 0. So that's your true or false, positive, negative, etc. And we're going to have a not null, and we're going to default that to 0. So in all cases where that's not specified, it's not going to be a return. And lastly, we're going to insert some sales notes, and we're going to use the varchar max. Now the max just simply specifies the maximum amount of characters that SQL can store within that column itself. So you can pretty much have quite a big essay going on in the sales notes. But it does take up a lot of storage on disk, so just be wary of using varchar max in your tables. And now to end the table, to close it off, once you've completed all your columns, we need to put in a round bracket followed by your semicolon, which again in the create table is not necessary, but again it's good practice. And that's it. That's it for the table. So you can either pause it and finish typing it out, or if you're very quick on the keyboard and you're ready to go, if you're happy with all that, we're going to highlight that, create table, and hit execute. And there you go, our table has been successfully completed. So let's go ahead and see where that is. Going across to the Object Explorer, expand My First Database, go down to Tables, and there you'll see it in all its glory. You can even expand that further, and you'll see the columns there and the data types themselves. Control R, get rid of that result screen, and that is pretty much it for episode 3. I have got some fun and games for you in the form of some homework. Excellent stuff. So what we're after, and this is just building on everything you've learned in this episode, is to write a set of queries in one query page. Remember to save it as you go. And what we're after is to create a new database called Internet Sales. Once that's been done, create 3 schemas, sale, product, and customer. And then once that's done, what we want you to do is create 4 tables. Now this is where the work really comes into things, but it is nothing that you haven't covered so far. So we've got 2 tables in the sales schema, orders and order line, with a few columns in each. And going down a bit further, we've got the product details in the product schema, customer details in the customer schema, with a few columns in there. And answers will be in the next episode for you. So please go ahead, carry on, do that, and by all means play around with everything you've learned here. Create as many databases as you want to, build some schemas, build some tables, do your homework, and we shall see how you went in the next episode. And that's it, ladies and gentlemen, for episode 3. Thank you all for your time, and I look forward to seeing you in the very next episode. Have a great day.